Hi, my name is Bill Gibson, and I'm a program manager in the Azure SQL Database team. In this video, I'm going to introduce you to a sample application and patterns that you can use to accelerate development of SaaS applications on SQL Database. There's been an explosion of interest in software as a service, or SaaS. Whether you're migrating existing packaged software or developing new services, SaaS application development presents many new challenges, not least in database management at scale, with many SaaS applications needing to support many thousands of tenants or more. In fact, on SQL Database, the largest applications in terms of database count are all SaaS applications. In working with the developers who have built these apps, we've been able to define a set of SaaS-specific design and management patterns. We've then taken these patterns and produced a sample SaaS application, plus a set of management tutorials that can help you accelerate your own project. You can deploy the sample application into your own Azure subscription in less than 5 minutes and work through the management tutorials at your own pace. The tutorials are all online, and the code, scripts, and templates are in GitHub. So, let me introduce you to the Wingtip Tickets application. It's a simple event management and ticket selling application for venues, theaters, pubs, clubs, etc. It's a multi-tenant app where each venue is a tenant. Each venue then gets a website customized for their venue type where they can list events and sell tickets. The application holds data for each venue, lists of events, as well as ticket purchases and customer information, and so on. So, how should all this data be stored? When we talk to SaaS developers, they tend to have 3 key data management concerns. Cost per tenant, particularly if the application is targeting a low price point. Scale, can it handle the number of tenants? Can it handle the amount of data and the workload that is anticipated? And tenant isolation, not just in terms of data isolation, but also performance. Will one tenant's workload impact the performance experience of other tenants? With these concerns in mind, as you think about the database design behind the application, the first issue to address is the tenancy pattern, how tenants are mapped to databases. Now, there are several design patterns you could use. Let's look at 3 that are particularly interesting. The first pattern uses an isolated database for each tenant, installed as part of a standalone application stamp. Each tenant gets a copy of the application and their own database installed in a separate Azure resource group. The resource groups can be deployed in the software vendor's Azure subscription or in the tenant's subscription and managed centrally by the vendor on the tenant's behalf. If you're migrating an existing software product, this pattern may require little or no change to the schema or queries used in your application. This model also provides the greatest database isolation, but requires that sufficient resources are allocated to each database to handle peak loads from its tenant. As each stamp is fully isolated, operational complexity scales in line with the number of tenants. So this pattern tends to be used in scenarios involving fewer and/or larger tenants. The next pattern uses a multi-tenant application, but still with a database per tenant. In this pattern, the application tier is scaled independently of the database tier, and both are managed centrally by the vendor. Again, if you're migrating an existing application, the database schema and queries may need only minimal change. This pattern needs some way to manage the mapping of tenants to databases to enable the application to connect to the correct database. SQL Database provides a sharding library that is used in conjunction with a database that acts as a tenant catalog. The library, available in Java and .NET, requires only a small change to the way your application makes a database connection, and provides both catalog management and efficient connection handling. Like the standalone app, the use of single-tenant databases gives strong tenant isolation. And as databases are deployed in the same resource group, they can be placed in elastic database pools, which provide a very cost-effective way of sharing resources across a group of databases, and can significantly reduce database costs. With careful configuration and management, pools still provide a very high degree of performance isolation. This pattern also scales well, with many customers having tens of thousands of databases, and the largest deployment having over 150,000 databases in over 300 pools. The third pattern uses a multi-tenant database, which requires the schema is modified or designed to hold data from multiple tenants in each table. This pattern suits scenarios requiring perhaps less data per tenant and not needing the same levels of data or performance isolation in the previous patterns. While a single database can be scaled up to hold many tenants, near limitless scale can be achieved by scaling out and sharding the data across multiple databases. As sharding adds additional constraints on the schema, the decision to use this pattern is best made at the beginning. And once tenants are split across multiple databases, a catalog is required again and can be implemented using the same sharding library as before. And while this is intrinsically a multi-tenant pattern, you can choose to isolate single tenants in a database of their own. These single-tenant databases can be hosted in elastic pools to provide cost-efficient resource management. You might use multi-tenant databases for tenants who infrequently use the service, and single-tenant databases for more active tenants or those paying for a premium service. SQL Database also provides a split merge application, which enables tenants to be moved between databases without impacting the application. So, which model should you use? Well, the standalone app is the simplest model and provides the greatest isolation, but does tend to incur the highest per tenant database costs and is more complex to manage at scale. The database per tenant model, used with elastic pools, offers a high degree of tenant isolation and potentially much lower per tenant costs. Many features of the SQL Database platform have been optimized to help manage large numbers of databases, so the high database count that comes with this pattern should not put you off this approach. And then the multi-tenant database model trades lower per tenant costs for reduced tenant isolation. Using sharding provides effectively limitless scale, but does introduce additional complexity. The sharded multi-tenant model also offers the option to mix multi-tenant and single-tenant databases in one solution, which may be interesting. So, which of the three tenancy models is used in the sample? Well, the answer is all three, with 3 versions of the sample application available, so you can explore the impact of each model on the application's design and management in the tutorials that accompany each version. The tutorials show you how to deploy the application and then explore a series of interesting management scenarios that highlight some of the SaaS patterns. You can explore tenant provisioning to see how databases are created, and the sharding library is used to manage a tenant catalog. A load generator is included that mimics unpredictable tenant loads common to many SaaS applications, which can be used to explore performance monitoring and management, including load balancing of pools and handling isolated hot tenants. You can also explore schema management at scale, seeing how to set up and run jobs to deploy schema changes to an entire fleet of databases. And in one tutorial, ticket data can be generated for a batch of tenants, which lets you explore cross-tenant distributed query and analytics scenarios using Power BI. This highlights the incredible opportunity you have with SaaS applications to gain insight and value from your tenants' data. And you can see how to restore a single tenant to an earlier point in time, and then try out a disaster recovery drill and recover the entire application with its databases into another Azure region. We're continuing to build out the sample and would love to get your feedback on any scenarios you'd like to see added. You can use the links on the screen to find out how to deploy the application and explore the tutorials. Please use our SaaS feedback alias to send us any comments on the samples and any questions you have about implementing SaaS apps on SQL Database. And if you have a couple of minutes to spare and are willing to complete a quick survey, we'd love to learn more about your SaaS journey. Well, that's it, and thanks for watching.